Good morning and hello everyone, and welcome to today's webinar on selection of plastics for everyday products. I am the principal of School of Postgraduate Studies, Mr. Gibson. At the outset, I would like to thank you for registering for this webinar and taking your time to be here with us today. Today is an interesting chapter where we deal upon plastics, where we always say that for the last 3-4 decades, plastics have been around us, giving us comfort, convenience, safety, and many other aspects. To get into all these things, we have two speakers today to give you the insights of what plastics can do in our lives. Before we start, if you have any questions during our presentations, we request the participants to use the Q&A function to send the questions at any time so that we will be able to answer your queries during our Q&A session. Let me introduce the first speaker, Ms. Dr. N. Ramani, a stalwart of around 53 years of experience. Okay, so he spends a lot of time skilling the youth, and his immense and rich experiences in NTTF School of Postgraduate Studies would give you insight to the next 10 to 15 minutes about the plastics and how we can benefit and how we can learn much about this particular topic. Over to you, sir.
Good morning, my dear viewers. Today, we are glad to make a small presentation to you on the application of plastics in day-to-day life. In the morning, a person wakes up, you may see that clock shows 10:10 because that person has had a long day into the night. So he has set the alarm at 10:10 probably. It's completely made out of plastic. Then he brushes his teeth using nylon bristles and a plastic handle. And the tube containing the paste is also made out of plastic. And then he takes a hot cup of coffee in the plastic mug. And then he goes for a bath. This is plastic bucket. He uses a plastic mug. And of course, the soap case is made out of plastic. And he uses his cell phone extensively, which is made out of plastic. And the material of the clothing that we wear is probably mostly out of synthetic material. And the shoes that we wear, these non-leather shoes, which are made out of high-strength fibers of plastics. Thus, we come to a conclusion that it is impossible for us to lead a modern life without plastics at all. And if you open the interior of any car, modern car, you will find that everything is entirely made out of plastic. And if you completely dismantle a car and put it like this, excepting the body parts which are made out of sheet metal, most of the parts are out of polymer, including rubber. And what are the advantages of plastics? Why is it that plastics is the most preferred material? Because of several reasons. One is it has got lower density compared to steel, for example, or metals. So steel has got a density of 7.8 specific gravity, whereas this is just around 1. And you have to protect the steel against rusting by painting or plating. Here, you don't have to do anything at all. And if you want to improve the aesthetic appearance, it could be painted. And it could be made transparent, some special materials. It can replace glass at a lower weight, giving the same transparency for the headlamp hoods. And they are very easily processable because of lower temperature of melting. And they are durable for the life of the car, absolutely no problem at all. And earlier, we used to have bumpers made out of steel. That was as a protection for the car, we thought. But then we learned that we need a material which will have high impact toughness. When the impact comes, it will absorb the energy and spring back to its original condition. That is why the modern bumpers are made out of plastic, and they can be joined by welding easily. And if you want to improve the aesthetic appeal of the plastic parts, they could be painted also. And it offers tremendous amount of flexibility. I'll give you an example. In moped, we had what is known as an engine shield, which was made out of deep drawn material. And then after deep drawing, it was trimmed. Then it was pierced. Then it was spot welded. Then it was painted. Then only it was ready for use. Once we changed it to polypropylene, my favorite material, it was easy. In one stroke, the injection molded component is ready for assembly. That way, it is overall cost is much less with plastic. Now, if you open the bonnet of a car, you will see so many parts made out of plastics. See, earlier, they were made out of cast iron. Then we changed them to aluminium. I started with Bajaj Tempo, the manufacturer of four-wheelers, in 1964. So I saw the gradual changeover of materials from cast iron to aluminium and then to plastic. And what are the advantages of plastics over metal? A little in detail. See, density of metal, let us say steel, is 7.8, whereas plastics around 1. So tendency to rust is not there at all, and transparency possible, possibility easier, durability quite sufficient for the life of the car or whatever, lifelong, I would say. Impact toughness is excellent. Joining welding is very easy. Paintability is not required most of the time, but if you want to enhance the appearance, it can be done. And design flexibility superior, and overall cost much lower. So what are these are 10 advantages. There are many more. I just selected randomly 10 numbers. One single major disadvantage of plastic is after its use, when it is discarded, it creates environmental pollution. So there are 10 advantages and one countervailing disadvantage. This outweighs this. Now we'll see one more slide before I close. What is against plastic? See, the low cost use and throw away plastics only cause pollution. It is not the high cost, high value plastics that are used in cars, they cause pollution. They can be reprocessed easily. Whereas this is low cost, made in millions and every day, and that is, they end up in oceans and waterways and cause major pollution. This is something which is subject to research, and one of these days we will be able to address this satisfactorily to the satisfaction of the whole mankind. With this, I hand you over to my guru and my senior colleague, Mr. K.G. Krishnamurthy. He has got decades of experience in plastics processing. I'll come back to you after he finishes. Thank you. Bye-bye.
Thank you, sir, for this wonderful introduction to plastics. Our next speaker, as Dr. Ramani said, Mr. K.G. Krishnamurthy, is our next speaker with around 35 years of wide experience in industries. He is one of the faculties of the School of Postgraduate Studies. And over to you, sir, for your thoughts on this today's plastics.
Hello, good morning to all participants, and thank you for the wonderful introduction by Gibson and very good cue from Dr. Ramani. So I consider it's a good opportunity for sharing some analysis on this particular topic. I'm going to help you think or help you analyze how the selection of plastics can be made. So that has got a journey to make. So in the course of another half an hour to 45 minutes, we'll be covering. I would be able to give you the way how we can do it easily. So I think, as Dr. Ramani put it in the earlier session, the plastics had been used in almost all the applications. It is difficult to identify any sector if it is left out of using plastic, except eating. You have used plastic everywhere. And if I extend this kind of analysis to one single statement, that there is no 1 minute in our life, any time in the day that we don't come across plastic. So plastic had been so much used in the atmosphere around us, whether it is medical, footwear, packaging, building and construction, electrical accessories and electronics, transport, agriculture. So in all these sectors, they are used. Obviously, there must be those properties which are really benefiting for using in all those sectors. Otherwise, whenever people design a product, it is always a challenge to select a correct material. If plastic had been occupying in these applications, there must be those properties which are friendly. And of course, as it was put in the earlier session, in some of the applications, because of the excessive use and to an extent a kind of irresponsible abuse, it is creating a lot of ripples in the society. It's only a question of getting alerted, and of course technologies are developed to reprocess those materials. Let me not get into that particular area of almost to say an interesting of course a lot of controversies over there. So why should we use plastics? Already a lot of the features are listed. So here something interesting what we need to do is, it has got highly complex part geometry you can design, a very complex part geometry. There are some part geometries, if you don't use plastic you cannot manufacture that part. Plastic is the only choice. So that way, that gives an advantage. And with the level of technological growth now, with the advantage of CNC and CAD and CAM, where a design can transfer from different points, even across the world easily, the complexities is no more an issue. And a lot of efforts are there made to develop plastics in a very, very interesting condition. See here, there is one point which is said as hygienic and clean room atmosphere parts. So now this is the time in COVID, we are more worried about growth of germs and virus. So it is possible now to make plastics which can resist that kind of a atmosphere, that kind of a threat, that kind of an attack from the virus and the bacteria. It is possible. I will just tell you later how is it that being addressed now. So the other properties are already known. See, one thing fundamentally we have to realize is, if any geometry you are designing by a plastic part, there can be no other material which can give you at that cost. So any geometry, plastic cost, the plastic part is the cheapest, provided you should know what are the advantages of plastic and what are the some kind of a constraints. Suppose you want connectivity between 2 points, then it is not a good idea to use plastic, because plastics are insulators. They are insulators. So that is one condition. And if you want heavy weight, if you want weight to be added, then plastics may not be a choice, because plastic is a lightweight construction. Suppose you are having an application where there is high temperature involved, 150, 200 degrees centigrade atmosphere involved. So there have to be special grade of plastic, or you have to go for alternative choices of materials. So let us see down now. I'm going a little faster. So here, when we try to analyze plastic, actually a big group of plastics are available around us. We have seen many applications. For our sake of simplifying things, we have to start classifying. So any basic volume of material you have, the best way to select what is suitable to you is try to classify as much as possible. So it is something like in a classroom when the students are there, we will classify students into categories like boys and girls, or we will classify into localites and people from outside, or we will classify the students who can score more than 80, or 60 to 80, or 40 and above, and who have got a tendency to fail because they have got some similarity within them. So here when we say commodity plastics, there is one kind of an application there. Engineering plastics is another category, and special performance or super plastic is another category. Let us see what is the exclusivity over there. This classification, if we are clear, when we are selecting, actually we can lay our hands onto the right type of plastic that is suitable for us. So commodity plastics, they are known because they are low strength material. You can almost break them with less force, and they are low melting point. What does it do? Low melting point leads to, it gives better processability, means you can melt, you can supply less energy and melt it. And it is a low cost material and easy to process. Overall, when the processing is easier and the material cost is lower, the part cost will be the cheapest. And here, if you see here, the list of products, I think all of these are very familiar to you: polypropylene, polyethylene, linear density, low density polyethylene, polyethylene terephthalate, PVC. We know very well it is used in plumbing parts, and some of the jerkins are made up of PVC. Polystyrene, it is polyester, and then ABS. So all these are some category of plastics, some type of plastics which are meant for commodity application. They are used, the application part of it, if we say packaging products, which is extensively used, most of all the plastics produced, packaging industry consumes nearly 30% of the total plastics produced. So that is the amount. They have an advantage because if there was no plastic packaging available, imagine transporting Coca-Cola from the factory to the consumer. Earlier they were using glass bottle. A glass bottle, you know what is the weight. For transporting 1 liter of Coca-Cola, you would have whatever the weight of the Coca-Cola is there, you would have almost similar, same or little excess weight of the bottle. That means a truck would be transporting the bottle half of its weight. But now with the availability of plastic packaging, you are able to bring it down to just some percentage of Coca-Cola. That means the transportation cost will come down. And can you imagine packing medicines? Can you imagine packing food without getting damaged, without getting exposed to moisture or contamination? So that plastic has given. But of course, we have to be careful in using those items in that application. And utility items, that means what we are using in the day-to-day life. Personal care items means what it was identified. I gave the simple example like the shaving items and the cosmetics packaging or the medicine packaging or the soap tray. So all these are categories. So plumbing parts, we know very well, they're all made up of material which is plastic, and the advantage is they're lightweight, doesn't corrode what it was listed before. Water can easily, you can easily pass them. They can join them because it was told you can assemble them, weld them very easily. Metal, can you think of welding a metal pipe and tube inside your home for putting plumbing parts? So it's not a practical situation. Construction engineering parts, where the houses built these days are using excessive plastics. And engineering plastics, the difference with respect to engineering plastic, the engineering plastics with respect to commodities, they have high mechanical strength and they are relatively expensive and difficult to process. So because of this, the part cost goes high. But look at the sample of the parts. I have just given a picture here. It's a gear train. There are some of the knobs, some bearing parts, some coupling parts. They are actually transmitting power. They are actually transmitting motion. So they have to handle that kind of a precision requirement. It has to do for a definite number of service life. So there, the category of plastics are fairly expensive, and they can be said as nylon, PC, POM means polyoxymethylene, which is also called acetol in the general market, polyphenylene sulfide. I have only listed a few which is frequently running around us. Nylon, if you know very well, I think when it was launched by DuPont several years before, this very word nylon actually means New York to London. So they made a fiber. The persons who are launching, they said to the world, we can make one fiber which covers from the distance from New York to London in a single stretch. So that is why they named it as nylon. So nylon became a very, very familiar material as far as fibers are concerned. Nylon fabrics came, and it is a very thin material and it can be drawn to thin fabrics. And they are the engineering plastics are used in connector parts, automotive engineering parts, instrumentation parts, where you have got strength as well as a little focus on cost. But in the commodity parts, cost is the primary criterion. And then comes, this is already, you have seen so many parts are being used in the car. Almost now it is increasing on a daily basis because plastics are being developed to handle a lot of the complication of atmospheres in that. Then comes the special performance plastics. Also it is called super plastics or high engineering plastics. These plastics are specially categorized because the properties are exclusive. The properties are customized, exclusive. How do we customize? We will see a little later. I will just share you one or two informations later. They have got strong thermal properties. That means they can withstand a little higher temperature. Imagine an exhaust of a vehicle is now manufactured by using a particular plastic. So exhaust temperature of the gases are very high. Earlier it was considered to be only metal domain. Now that is replaced by plastic. The advantage of using plastic is not because it can withstand the temperature, it's because the reduction in weight. Always in the vehicle, the target is to reduce weight because weight reduction brings better mileage and less fuel consumption. That is what the world is thinking. So if plastics is not the material there, then no other material can fill in this space. And customized properties are possible. The properties are customized. They are difficult to process and they are expensive. They are all special performance plastic. So some of them, if I can tell, PTFE, most of you must have heard, it is actually called non-stick pans. This is the coating they are doing, and polyether ether ketone is a very, very special grade of plastic, but they are very expensive. Expensive means I can just give you an idea. It will cost somewhere around 2,000 rupees per kg. The commodity plastics will be somewhere around 40 or 50 or 80 rupees per kg. Engineering plastics will be touching around 200 to 200 rupees per kg, the current prices. But peak and PTFE will be somewhere around 2000 and 2000 plus. So that is why they are used in medical parts, aviation parts, and special engineering parts. Medical parts, why are we worried? Because in medical terms, imagine a IV tube is prepared where the liquid or the blood is transported from the body to the machine or from the machine to the body. If you have got a part which actually reacts the blood, then the patient, on him you can't do surgery, you will have to do postmortem. So medical parts have to have special properties, and bacteria should not grow. It should not retain the blood contents of the earlier patient. So to that extent, the part is customized, material is customized. And there is another classification. Why we need classification? It is repeatedly again because they have similar properties, they have similar processing requirements. So thermoplastics and thermosets, we know very well the word thermoplastics means plastic is actually to, when you apply load, it will be deforming. When you take it out, it will come back like a spring. So all such materials are for plastic state. Heat, and you can, once you apply heat, it's gone. It just sets its shape. So, and these two materials have got similar mechanical, thermal, optical properties. Flow behaviors are similar based on the categories they have. Processability comes to the same condition. Availability forms are same. Thermosets, because once you process them, it is going to end its cycling condition, the processing condition. That means they will have a definite life. You cannot store it for a long time because it continues to undergo chemical reactions. And material costs, of course, based on the orientation or the arrangements there, it will be different. In thermoplastics, we have got two main categories, which are amorphous and semi-crystalline. Amorphous means all the fibers are randomly arranged. Semi-crystalline means it is similar. Based on these two, there are some properties of the material which is going to come. Maybe transmissivity, light transmission. Amorphous material, the photons do not get reflected back, they pass through. Semi-crystalline, they have got a crystal arrangement, the light will reflect back. And amorphous material, when you melt, you have got a longer processing range because it doesn't change the phase. Semi-crystalline, there is a change of phase. So the moment when you are processing it, when you cool down, at one point they become solidified. You cannot process further. So that way they have got a narrow processing range. So that is going to influence your selection of the plastic. So this is one kind of a classification what we have seen. The earlier one, this is a diagrammatic representation. So look at the range of thermoplastic parts you are able to do. Like what it was shown before, we have got knobs and caps and bottles made. The input material is same grain. And look at the trays, chairs. All these parts are made by the grain form. This you can get colored there. Plastics can be colored. So imagine if you have got in a house, 10 people are there and you are keeping soap trays there and all of them are using same soap. Then how do you separate every day when you are picking the right soap? That the soap reserved for me, I don't want it to be used by somebody else. That means the same tray can be made in different colors. That way you can differentiate. Automotive connectors. So the connectors are electrically conducting the signal. So the connector used for operating the light should not be used to operate the sensors, should not be used to operate the wiper. When you want to put on light, wiper should not be on. So that means you can separate, differentiate by coloring the parts. So that is advantageous. And another thing is, look at this part. This is a commodity item, a comb of different design. Can you think of this particular feature in any other material? Earlier days, this was made by ivory. So one comb would cost several thousands. Now it is banned. We know very well. Veerappan, people like him killed elephants because to collect the ivory. So look at this. This is actually, some of them are engineering parts, a telephone headset, the cables, the specs, the balls, the spoon, the bottle, and the zip, all plastic. And this is another category. All of these are raw material is grain form only. In between, some of the forms will have intermediate forms. So all of them will have. So what I'm trying to say is, plastics, it is actually proving that there is no 1 minute in our time we don't come across plastics. So this is actually thermosets and elastomers. Those are all thermoplastics where you can remelt and reuse them. Here, this is a material category which is called thermoset. You apply heat, they get solidified. So this is rubber material. This is also same thing. You apply heat, you can change the shape and you cannot change it again. So they are set to the shape. Maybe you can cut them and use it as a waste and scrap material or road pillar or construction application, but that cannot be reprocessed like the earlier category of plastic called thermoplastics. And this is a way in the market we are identifying. This is an ethical practice where for recycling, we need to know what type of plastic it is. So category 1, this is indicating recycling. So these are all named based on the consumption, have been given number. There is one category called 7 where all other engineering plastics are categorized into this, and we will have to write what is it, because this helps while you are recycling the plastics. Because if you don't know polyethylene terephthalate, the way you process, you cannot process polyvinyl chloride, because polyvinyl chloride, when you burn them in the atmosphere, you get dangerous gases, toxic gases. Polypropylene may not be possible to be processed, and polyethylene terephthalate also gives the flames. Some of them are dangerous to process in the home. You cannot burn them. That's why if you see in all the plastic parts, we say that don't burn plastic at home. So that is why, to help the people to recycle, there is an identification tag. The product designers have to provide this in a place where you are not going to make it functionally disabled. So this is another category of classification where homopolymer and copolymer, where before the process of polymerization, two monomers are mixed. Monomers means repeating units. So they are mixed. Based on the arrangement you are going there, you are going to get different properties. Look at this fiber. Alternating one is there. Block means one set of A and B means A 4 items, B 4 items, A 4, B 4. This continues. Or you can have A as a backbone and B monomer can be branching out. Or this can be random. All of this will lead to different properties. If you see the earlier session, I said earlier slide is the structural arrangement inside will change the properties of the plastic. What is it leading to? It gives different varieties of plastics. And polymers after polymerization are not fit for use. Directly, they are not fit for use. So we will have to make them useful. For that, we are going to add, the engineers, material engineers are adding additives. There are some interesting additives. See, anti-counterfeiting is possible. Therefore, that means suppose you are manufacturing a part suitable for medical part. Then in that case, if the vendor is changing the metal, how I told medical application, the material is special plastic. So in that case, you can have a coloring tag or a RF tag on the material. So when you process, you can check the part for the presence of the tag element. So you can do anti-counterfeiting, antimicrobial, bacteria will not grow. You can add that material, antioxidants, which will actually reduce oxidation. Anti-static, ESD is a bigger issue. See, static electricity is very dangerous in many of the products. Electronic circuits, they are very, very dangerous, because that kind of a shock, the electrical surge, the products will not be able to handle. So the plastics, being insulators, are basically static electricity friendly. So you will have to make them compliant. That means you will have to provide, you can add additives to make it ESD compliant, static electricity compliant. Then you can have blowing agents where you want to blow the material into a bottle or a lid or a can. So you need to have the plastic stretchable. You can have blowing agents. You can add lubricants. That means inside the two fibers you can have lubricants so that they will flow well. They will flow well. You can have colors. You can have processing aids, because plastic can be processed by many ways, which we'll see later. So for all those, there are definite properties required in the plastic. Even though plastics are low strength material, some of the times in the processing we will have a problem if there is no processing aids. Pillars and extenders are used for either to increase the volume or to add the strength. Flame retardants means, imagine suppose you have kept a coffee maker and you are not attending to it. In that case, the part should not catch flame. But a hair dryer, you are not keeping it and going away. So you are in the presence, if the plastic will work, or out of that. So fragrances can be added, heat stabilizers, impact modifiers, all these can be added. Then the polymer becomes plastic. So what is it leading to? You will get varieties of plastics. The companies will give you huge varieties of plastics. You know how many varieties of plastics are available? If you take a guess, it will be more than 50,000 items to choose from. So more than 50,000. So they can be allied also. See the advantage of allying and blending. Two plastics can be mixed. Two plastics can be mixed. The property of one and the property of the two can help you to develop products. Polycarbonate is a tough material. You can add some soft material to with acrylic. You can add hard material. So optical transparency as well as polycarbonate's impact toughness will come to the product. Like that, you can blend the polymers. But of course, we will have to look at whether they are compatible. All plastics cannot be blended with all kinds of plastics. We will have to just rate them and compatibility. So how are we processing plastics? Now we know very well the varieties of plastics are available and they are classified into different categories. They have distinct properties in that particular group. So you can process almost all the plastic processing methods have similar methods. Like you heat the plastic, particularly thermoplastic I'm looking at. You heat the plastic, you are ready to give a different shape. In that condition, you cool, it's settled. The shape will be retained. So if you force it with injection and into a chamber and allow it to cool there, it will become injection molding. If you take plastic thermoset materials, you load it into the tool and start polymerization, it will become compression molding. And if you heat the plastic becomes soft, at one point of time, you can blow air. That means the plastic will expand like balloon. So bottles are made with this process, blow molding. You will blow air. Thermoforming means you are giving a shape to the sheet of the plastic, which is the sheet is manufactured by extrusion. So that sheet is actually given a shape. So thermoforming is a process where we are heating the plastic, the sheet, and we are putting it onto a die and we are sucking or blowing air. It will take the shape of that die what we have made. So thermoforming, extrusion is what it gives different sections. Otherwise, if the extrusion was not there, we would not have had so many cross sections of PVC available for construction application. So there are many more varieties which I'm only limiting to this particular one. So why injection molding is more preferred? Because if you see almost all the parts, as it was said before, the injection molded parts become the largest type of varieties of plastics produced, plastic consumed. Even though weight-wise they are less, the value terms, the amount of volume, the varieties, injection molding gives the advantage. So you can produce from simple to complex, rigid to flexible, transparent to opaque, small to large. You can have with holes or with spring action, like you've got mobile cover, or you can have bottle with lid. See, these are all simple parts and complex parts. Look at the gears here, they're complex, and you can have rigid parts like a plumbing item, or even you will have what is used in the polycarbonate mixing jars, or you can have soft material which is flexible, and you can have a transparent material, or you can have opaque. These are all colored, they're all the parts of a pen. You can have transparent, all these are molded by injection molding. Look at that. And then small parts used in the watches, these are all used in instrumentation. These are all used in automotive application. Look at the large parts used in the bumper, used for the dining table and the chair. They're all molded, injection molded. The process is same, but the amount of material used, the type of material used, and look at this here, you can even color them. The same bumper can come in different color. These can be made in different colors. Look at the chairs, you can have multiple choices of colors in the part. Then comes, you can have single color Lego blocks, what is shown here. All of these are with different material, and this is multicolored, means in the same part you can have two materials loaded into one. Then comes parts with holes. These are about many holes in the part, like filters, and this is like a spring action. So these are all injection molded material plastic. So injection molding means what? In simple terms, if I tell, melt the plastic, force it into a chamber of the shape of the part, then allow it to cool. So that will give the part the shape. So when it is solidified, the shape of the part will be set. Of course, there are issues involved. Everybody cannot design a tool because it has to prepare the material, or it should have to give the shape of the part, what the design of the part looks like. So it's a very complicated, it's a very challenging field and very, very interesting field as far as injection molding tools are concerned. So injection molding, let me repeat, melting the plastic granules, because granules you have seen here, this is the input material for the injection molding. This will be the type. They are all melted. The machine will melt the material, that will become a plastic melt, ready to flow liquid, and that will maintain a temperature. The machine will have to maintain consistent temperature. Then you are forcing it into the cavity in the tool. The impression of the part, replica of the shape of the part is created in an arrangement of the tool. Sometimes, you know, tool is so challenging and so expensive. Some of the tools are more expensive than the machine. The machine may cost 40 lakhs. The tool will be costing somewhere around 50, 55, 60 lakhs. That is the type of technology that will go into the tool. Tool building is similar to building a machine. These days, it is similar to building a machine. Why that is being developed like that? Because plastics, because of the development of the molding tool technology, the designers are able to think of wonderful shapes on the plastic part. And because plastic can take, it is possible to manufacture the part. So the part designers have got no limitation now. So they can design anything, and the injection molding tool can help them to manufacture that. Cool the melt after the filling of the cavity with the high pressure material. It has to be cooled because plastics are to be cooled for solidification. Of course, there are issues like the size of the molded plastic and the size of the solidified part will be different. The tooling engineers will take care of the size differences and they will maintain the tolerances, and you can produce in mass. There are situations where the tools produces in one shot, they will produce 128 parts, small parts, so much you can produce, so much of technology it can take with. And after giving a shape, you have to eject the part. That is the most interesting part of the tool. So you will have to eject the part safely. You cannot simply eject so that the part gets damaged. You have to eject in such a way that the part doesn't get damaged. So you will have to have a proper mechanism. So this is one process where the injection molding helps. This is one sample part. This is the resulting part. This is a simple analysis for anybody to understand. The tool will have, for outer shape, there is one part of the tool. The inner shape of the part, there is another part. The inner is called core area. The outer part of the tool is called, the item which gives the external shape to the part is called cavity. Those two are every time closed, and there is an entry for the material to come, that's called the gate. So it enters into the chamber. The tool will be cooling the part, and after opening that, you can eject the part like this. So a finished part will be of this shape. So this is a simple conventional extension of how the tool works, because this is the core area, because this gives the internal surface of the internal details of the part. In the top side, actually, you have got the external details of the part. It's called the upper side or lower side, or it's called fixed off and moving off with respect to the machine, because this moves every time. This will be fixed to one side, one plate of the machine. So this will be moving, and you have got a pocket here where there is an ejection mechanism. So after the tool is opened, the part will be ejected. Will that be a simple tool? Look at the next part. This is the real tool. This is the part produced. And there is one part here. Look at the tool here. So this is the most complicated tool, whereas this tool will cost, a simple tool may cost a few thousands. This will be few lakhs. This will be few tens of lakhs, because the part in the molded condition, when the part is ejected out, will have several mechanisms working in the tool. That is why I said tool making is not a simple activity. It's a special process. But as a process, you need to know. So this is actually a mold of a thermoplastic. What I said, recycling. That means this is the spoon manufacture. This is an area where the material enters into the chamber, and this is called the sprue. This can be recycled. That's what I said, we can reuse them. So that is the advantage of thermoplastics. Then comes, now let us come to the final stage. It is almost reaching the final stage over of the matches. I told you more than 30,000 types of plastics are available. Is it an easy choice? It's not going to be easy. But the categorization, the study of the property, the study of the application will help you better. Let us see what is the way we can do that. And whenever we have got so many choices made, I remember to quote one situation here. There was one textile company which was very strongly contending in the market. They launched men fabrics for the pant and shirt, trousers and shirts. They launched with more varieties than the market leader. The market leader had only 3 or 4 colors of pant material. These people launched 10 colors. But actually, you know what happened? The people, because the choice was too many, they stopped selecting it because they were not able to select. But in the company which was offering only 3 colors, they were able to get that. So what I'm trying to say here, when you have got more materials, your choice should become complicated. But there is a science to select. There is a method, there is an approach. So we can select, because the exclusive materials are meant for applications where you will be very, very comfortable with. Suppose if you do a mistake in selection of material, what will happen? It may not be economical. Basically, finally, the economics will go up, or it may not even meet the design intents. The part, the designer, whatever he has planned for the part, it may not work. It is something like you are producing a body of a car voltage stabilizer by using fabric cloth. So will that work? It's not going to work. It's not a recommended one. So that way, actually, we will do a mistake. So what are the factors affecting the selection of polymers? We have to see what is the mechanical factors. Mechanical means almost functional. Type and magnitude of the normal service. How is it served in the shop? For example, if you take a simple product like a toothbrush. Toothbrush, when you are using, actually you are pressing the brush against your teeth. The teeth will not break, but the brush should not break the teeth. So it should be flexible enough. That is the type of service we need. It should be flexural. It should have a spring effect. And how are we loading? We are not loading by, 2 people are not brushing in one to treat denture. So one person is brushing, it should be designed for that load. How long it is going to take the load. Fatigue resistance, that means how many times it will be reversed. Then deflection allowance, how much it can bend. And overloads and abuse. Do you feel the toothbrushes are not abused? I have seen some people using the toothbrush for cleaning the sink, for cleaning the table, for cleaning even the washroom. So they use that. So abuse also you may have to design. So you should not design the product in such a way that when they are abusing, that may break and it may create accidents. So we should have to design the product for abuse. The material should be selected for abuse. And toothbrush or soap tray, people may drop from a height, it should not break. It should be impact resistant. Then comes the thermal factor. That means coefficient of thermal expansion of plastics, you may know very well. There actually plastics come to the, compared to metals, plastic has 10 times the expansion. I think most of you may be aware of it. plastics expand 10 times. The steel expands almost 11 microns, 11 to 14 microns per meter per degree centigrade, but plastics will expand even up to 0.2, 200 micron. So whenever you have got two parts made of different material, the metal enclosure with the plastic cover, then you will have to remember plastic expands more. So you will have to give scope for the plastic, and you will have to, whenever you are selecting the plastic, you should know there is a mismatch. The specific heat, that means the amount of heat required to melt the material. Operating range of temperature, will the plastic part work in a different range of temperature, what product you are designing? So there are range of materials suitable for it. So you are seeing commodity engineering and special performance. Is it a special performance? Is it a general engineering? Then maximum and minimum service temperatures. That means in the regular working, what is the service temperature it is working on? Will it be carrying hot water? Will it be carrying cold water? Will it be carrying insulation? Or what is the type of materials passed through that? These are all the different thermal properties. Heat deflection means when you apply load in the different temperature, the part will deflect. So the part should be, material you are selecting should have to withstand that. And then softening point means when you put a pointed load at a different temperature, the pointer will go inside. So that is a test. So the plastic should be tested for that application. Flame testing means, imagine you have manufactured a part for an aeroplane and you have supplied it, and whenever there is a heat developed, the plastic catches the fire. What will happen in a plane? Can you train people, all the passengers traveling there, to fight the flame? And plane is filled with petrol all around, so it will catch the flame, go in flames. So all the parts used in plane for weight reduction, plastic is used. So all of them should be resisting the flame propagation. That should not propagate the flame. So you will have a flame testing grades. Then environmental factors. Are we storing petrol? Are we storing hydrochloric acid? Are we storing alkalis in the tank? We should have to know that. Then will it react? See, for example, maybe most of you may be aware of, when you want to carry petrol, you always better carry a polyethylene terephthalate black PET bottle. It's a very soft material. Thinking that a polycarbonate is a tough material, if you carry petrol, you know what will happen? After 10 minutes, the petrol will eat away polycarbonate, because amorphous materials are not resistant to attack of chemicals. So you cannot use amorphous material. You have to use semi-crystalline material. So that way you will have to see what is the environment it's working on. I have seen some vehicles designed with plastic tanks. Fuel tanks are designed because the plastics doesn't have corrosion problem. They do not corrode. They can be made leak proof, and they can be lightweight product. Water absorption effects. There are some applications where water is absorbed. Look at the soap tray. Soap tray, do you feel it's a serious factor? It's important because it is kept in the bathroom. It is not kept inside a fridge. It is kept in the bathroom. So what will happen if the water is absorbed? Or what will happen if the water stays there? Bacteria should not grow. Imagine if the material is used in the medical application inside an operation theater. Can you have a plastic which will, with the presence of moisture, will grow fungus? You cannot even think of. But plastics are available. You can customize. You have seen the additives added. You can get that particular grade. So that will influence. UV light exposure. You know how dangerous UV light is. If you just test yourself. You take a tumbler and keep it exposed to the sun for 1 week, and you will see they rupture, they break up. But the same way, almost similar material is used to make the parts of an automotive two-wheeler. You park it outside, but will the handle outside cover break? Because they are made with UV light prohibitors, so it will not damage the plastic. So erosion by sand, because there are some parts where it will have to withstand the erosion by sand and rain. Bacteria and fungus attack is used for food products, or storing the chemicals, or storing pharmaceuticals. So all the electrical factors. The switch body is made by electrical plastic material. Can you think of making it by metal? It's the worst material you can select for that application. Dielectric factor is meant for charge part. Anti properties are told. Degradation, toxicity degrades, the plastic degrades. Tendency to release toxic items. You have to. I think you must have seen the part toys are produced. We will means even if the child chews it, doesn't create the child. It will not damage the, and rather it is not even dangerous. There are some plastics which are actually toxic. There are some plastics. Toxic means need not cause, it causes allergy, is very, it also causes deaths because it is a reaction of the body. In case use that material. Imagine materials which are allergic, plastics which are allergic. So you will, you may have to do postmortem surgery. Just dimensions, the weight factors, how heavy it is or how light it is, an important issue in that part. A space limitation, is it possible to fill that part inside that space? And remember one thing, plastics or replace all metal plastic. The strength of the metal, what it does, the part will get bigger. Is there space for the plastic to fill there? So simply replace the plastic, because plastic having its own limitation. So we will have to see whether the whatever space provided will the plastic there. So are you looking at this which is extended? So we will have to consider the factor. Acceptance code specifications. There are some industries which will have acceptance code for any part to be accepted. You will have to become acceptable for that application. Manufacturing. So choice of process for that material. We are seeing different for that manufactured. What is the option of the method of assembly? How are you assembling? Finishing and decoration. Why is it important? Because if you are having a situation where water should not, then you will have to produce welding gasket. So our gasket material react. So that puts you into a kind of process. A finishing and decoration. You have some plastics can be painted, some plastics can be decorated. So what are those and quality requirements? What is the quality level? Can this plastic give that kind of a quality performance? Ultimately, this is what the business is worried about. Material costs. That is, what is the cost of the material? Because of the three categories of cost, that you have different types of plastics. Ingredients add the cost of the material will change. So cost of capital equipment, because for processing this material, you have got so many things. So you will have to see what is that cost. They're all going to the cost of. So these are all influencing your selection. Now you know what material selection is such a interesting, simple, and complicated steps. Let me see how you select. Now this is the climax of this stage where you can develop your own approach as to how. The first stage in the selection of material is list and analyze all the functional requirements in respect to plastic. What are the functional requirements of the ergonomic designs means strength, aesthetic means look part of it, manufacturing guidelines means can you manufacture by molding or blow molding, or then quality and requirements, storing, how are you storing them, how are you transporting them, all these will help range of material. How are you manufacturing the part? Do you need blow molding? Do you need we will have to see the processability. All material processed by all the processes that we need to remember. And final cost. That means in a selection of the section requirement, processability, and the cost. Suppose if the cost is the priority, then it becomes common, because it is the primary consideration. Like the outer cover for the leg of commodity. Engineer, suppose gearbox, a transmission element. So that needs to have cost is one factor, but functional is important. And special performance, function, and the proper important cost is ignored. Cost is ignored. They are ready to pay even 2,000 rupees per kg. That is how the categorization. So suppose we take one simple example. I will come to this manufacture. Let us see how do we list the functional requirements, right? Because you cannot made up of. Then it should be colorful, because I told you the example that to have the same soap when they are used, you need different colors. Not react with chemicals used in the chemical product. Should not whatever the material used in it should not react, because people may drop from a height. Then should not get affected by water, because it is kept in the bathroom. Soap, when you are using, your be protected from that, and it should not grow. Because you use a plastic material where bacteria, and when you use tomorrow next of selecting to bacteria in different sizes and designs, because where people want to frequently different designs. Materials should be possible to be processed different designs, different geometries. The soaps are not available in standard size. I got 25 millimeter, there is a 25-gram soap, 25 grams more than 2 days. And house you have got family size 150 grams. The soap tray should be able to handle that kind of a size. So you should be able to handle. And when you are handling, you are you should be able to reach the soap very well, and you should be able to pick them up. And soap should not stick to the tray, right? So these are the ways you are aligned. Now let us look at the material you are. Can you select material? Some of the requirements of the product metal does not meet. I told it should be not affected by water. Suppose you use a normal steel sheet, it will get rusted. The rust goes to the soap. The stainless steel, it will have sharp edges. So we'll have to add extra process to make it burr-free. Because while you're taking the soap, normally you will keep your eyes closed. That time you will not touch the burred edge of the part. Then glass, can you imagine glass dropping from a height? So you cannot use glass. And ceramics, of course, naturally, is a very hard, brittle material. Maybe for style you can show, but not for regular use. Composites may not meet the requirement because composites are expensive. They are very expensive. Plastics, of course, that's a wonderful choice. It meets most of the functional requirement of the soap tray. In plastics, you have got choice of material: thermoplastic and thermoset. Is thermoplastic good? Thermoplastic is reusable. You can use reused material to manufacture the soap tray. So that means thermoplastic is better. Thermoset, they are stronger, tougher, harder, but they are brittle. You drop from a height, it's gone. Do you need the property? They are thermally stable. We are not putting the soap in a hot condition. Hardly the bath temperature of the water is around 70 to 65 to 70 degrees centigrade. That temperature it should have to withstand. We are not cooking food in the soap tray. So this way actually the selection of plastic material becomes interesting and becomes challenging. And remember, to conclude, I just want to tell one simple statement. That is, there are different materials for the same process, same application, and the same material used for different application. It is something like vegetable. Same vegetable is used for many application, many dishes, and for the same dish you can use many vegetables. The choice depends exclusively analysis of the cook, who does it. There are some choices which are very helpful, some choices which are very dangerous. Suppose you are making a sweet is, you want to make it very, very friendly and hygienic and nutritious. Garlic is a very good material for food. It has got medicinal qualities. You cannot think of adding garlic to any sweet. That will become a dangerous choice. You cannot use that. So we, as a material selection process, need to know what are the functional requirements. We need to know the lesser do's and some don'ts. Like in the soap tray, when you use glass, imagine the consequences. So this way actually material selection, particularly for plastic, day to day for an engineer, day to day or every day or one day or once in a week, may not make a difference as far as the manufacturing, as far as the selection of material. He is looking at, along with that, he is looking at how they are processed, what is the type of material, whether the customer accepts that, whether the design intents are met. All these will help the material selection to be a better scientific choice. Thank you for listening to me. Thank you.
Thank you, Mr. Krishnamurthy sir, for the lovely insight what you gave to all the participants here. It was quite lively session, and I hope that everybody would have gained a good insight on what plastics can do to our lives. Definitely, there will be a lot of questions which would come up. Before that, I would ask Dr. Ramani to end the session by giving the insights on what SPG could do, postgraduate School of Postgraduate Studies could offer, and what others could benefit on a long run. Over to you, Dr. Ramani sir.
Good morning once again. This on the left top of the screen, you see the imposing 5-story building in the Pina campus of NTTF, and the postgraduate programs were started in the year 1983. Yeah. And there are two types of programs. One is the PGT, postgraduate degree in tool engineering. It's a 2-year duration. It was started in 1983. So far, 560 graduates have come out of this, and they are gainfully employed throughout the world. Then we started a 2-year postgraduate degree program in product design and engineering in 1998. 272 students have graduated so far. Then we have postgraduate diploma program in tool design, which has started in 2002. More than 600 students have graduated. The popularity of this program is that within 1 year of your BE, you get employed in the industry very well. That is why it's popular. And then we started postgraduate diploma in quality engineering and management, which started in 2005. So far, 154 students have graduated from this. All the NTTF programs are recognized by the industries since the day one, and it is evidenced by the campus placement of all eligible candidates. Now, people, the industries who come to campus for interview for selecting the students are from Ashok Leyland, Autoliv. Autoliv is the world's largest automotive safety equipment and manufacturing organization. More than 60% of India's automotive demand is met by the Swedish company. It is near Bangalore. Bajaj, Brakes India, and then Caresoft Global, the Caterpillar, CN Technologies of Hyderabad, Delphi TVS, and then Fiat, General Motors, Harita, Kangaroo in Punjab. They are one of the world leaders in staplers, and HCL, John Deere from Pune, LGB from Coimbatore, L&T, Schneider Electric, Subros from Delhi. They are India's largest manufacturers of car air conditioning equipment, and this connectivity of the electronic connectors, and Turbo Energy Limited, TVS Motors, and so for more than 14 to 20 of our graduates are working in TVS in various departments. Sundaram Clayton and Whirlpool, and NTTF started one movement called TAGMA, Tool and Gauge Manufacturers Association of India, in which there are 450 tool rooms and manufacturing organizations are members. So they are familiar with the name of NTTF. So the moment a vacancy is there, they ring up to PG school asking for placement. And you can secure your future through NTTF PG school. Some student, one of the listeners asked a complex question. He knows that it's complex, face-changing material. When you find that you feel that it's complex, you can add your email ID. We will send you a detailed reply. Because if you start explaining a complex problem and solution, others may not be of interest. So I wish you all the very best. If you want to have a bright future in these unsatisfactory times, you can think of joining NTTF postgraduate school. Wish you all the very best. And any company's representatives who are listening to this, in case you are interested to have a very detailed training for your employees, you can contact NTTF. Wish you all the best. Have a great day. Bye-bye.
Thank you very much, sir, for giving the insight of what School of Postgraduate Studies could offer to budding engineers who can build up their career strongly in any industry. So we have come to the end of these sessions. We would like to take some questions. We have some few questions. We have a few 5 to 10 minutes time where we would like to answer some of your queries. And if you have any more queries after this, please put it in your Q&A session so that we will be able to answer all your queries as much as possible. In case we are not able to answer some of the queries, please share us your email IDs so that we will be able to get in touch with you after this session. Okay, so let me take up some of the questions. we have some. Okay, one question was asked about triangle symbols found in plastic bottles. I think you would have got the answer from the presentation which was done by Krishnamurthy. So that is recycling details for different materials. And then a question from Mr. Jeevan. Can you give quick overview on composite materials in plastics like SMC? Dr. Ramani sir, if you could, just give a brief, and more of this, we can answer you separately, privately. But for the information for all the participants, I would ask Dr. Ramani to speak. Sir, could you speak after unmuting your mic?
See, composite has got two things. One is the reinforcing material. The other is the matrix. Now, our human body itself is a huge and excellent example of composites. See, the outside is skin, which is for presentation. Real strength does not come from skin, it comes from the bones. So they got two things, the bone which gives you the strength, the flesh and the skin covers it. So you got both flexibility as well as strength. So sheet molding compound, it has got a limited life. The moment you have to store it in a refrigerated condition and you have to mold it within the time. So it's a subject by itself. We can have a separate presentation on that one of these days.
Okay, thank you very much for participating. I hope you had a good insight to what is available in School of Postgraduate Studies, as well as what is in offer for the next few weeks. We look forward for bringing you many more presentations like this in future. Enjoy your day. Have a good day. Thank you very much. Bye-bye.